Well, thank you, Kathy, and thank you all for being here. It's really great to see a lot of familiar faces here and old friends. As you just heard, I'm going to tackle the first part of this presentation. There will be two parts. I will be tackling the science briefly. I'm going to touch on climate change and some of the impacts from climate change, including coastal acidification, ocean acidification, and finally talk about some of the impacts, these consequences of climate change are happening to marine species. But before I start, I want to preface this by saying that climate change is happening faster than we could have expected. Our bay is changing rapidly. And it's changing so quickly, we've had to change the way we collect data on the bay. For the better part of 3 decades now, we've been going out once or maybe twice a month and collecting measurements on the health of the bay. And we'll continue to do that, but we've had to add to that program. We now have a continuous monitoring station. We hope to have a couple more of these. And it may look humble, but this allows us to collect the additional data we need to really understand the variability in the bay and to better understand acidification. And it is going to be hard to see, but there's a dark cylinder here, which is a data logger. It collects the data, it provides battery power. It's connected by a cable to a carbon dioxide sensor here. And in the back, there's a white PVC tube here with additional sensors for temperature and salinity, for oxygen. Everything needs oxygen in the bay, just as we do. There's a sensor for pH, and you'll hear more about that. It's a measure of acidity. And finally, a sensor for chlorophyll, which gives us an idea of how much algae is in the water. We've only had this for about 2.5 years now, but it gives us the much higher volume of data we need to really make better decisions. So, to start with the actual presentation, climate change. And this will be very brief, and hopefully everyone's already aware of this, but just in case, the more fossil fuels we burn, like we're doing here as you drove here tonight, actually, the emissions from your automobile, or emissions from power plants or other industry. The more fossil fuels we burn, the more carbon dioxide we're pumping into our atmosphere. Carbon dioxide is a primary greenhouse gas. The more carbon dioxide we get in the atmosphere, the more it serves to blanket the planet, trapping heat and warming the planet. And because of this, there are a number of consequences. I'm just going to touch on 3 of those consequences. But as our planet warms, so do our oceans, and so does Casco Bay. This is Friends of Casco Bay data going back 26 years or so, showing an increase over that time in our water temperature. And this is important because as the water's warm, many species may be migrating north. The critters that live in Casco Bay have a fairly narrow temperature range. And as our water's warm, they're going to move north to find cooler temperatures. And at the same time, critters from the south will be moving up into Casco Bay as their waters become too warm. Warmer water also holds less oxygen. And as I've mentioned, oxygen is critical for a lot of marine species, for all marine species. So a warmer bay will end up with less oxygen, and it's not a direction we want to be going. So one consequence is these rising water temperatures. Warmer water also takes up more space and leads to our next consequence, our next impact of climate change. This is sea level rise. This is not our data. This is data from Portland Harbor, however, over the past 100 years, showing this increase in sea level. You may have noticed over the past weekend with the king tides, with the high spring tides, preview of what is to come as we get more flooding from sea level rise. We'll obviously need to tackle infrastructure changes. I am very concerned about those shallow water habitats like eelgrass beds, salt marshes that need kind of a lot of light in shallow waters, and as our waters get, as our sea levels rise, there'll be less space available for those important habitats. A third impact from climate change is increasing precipitation. And again, the graph in the upper right is not ours. It's data from the state of Maine, however, looking again at the past 100 years. And we're seeing an increase in the amount of precipitation. We're seeing more frequent, more intense storms. We now have about 6 inches more rain on average than we did 100 years ago. And what we're concerned about is what you're looking at in the image here. This is a great view from the top of Eastern Prom, looking out over Casco Bay. Hopefully everyone's been here. The discoloration of the water is from the Precipitation River. The Precipitation River is off towards Sarah, off to the left there. And this image was taken after a major rain event. And what you're seeing is everything run off land in the heavy storm, ending up in the river, ending up in the bay. You can actually see the plume from the Precipitation here. And although it is Precipitation River water, it's anything but fresh. It's carrying with it all the stuff that was in the land, including nitrogen. So as we see these increased precipitation, more rains, more heavy rainfall, we're going to see more runoff. And that runoff will include nitrogen, whether it's from fertilizers that you put on your lawns, your gardens, or from the sewage treatment plant effluent, or fertilizers from agricultural areas, or just the amount of impervious surface in our urban areas. Whatever the source, we'll see more nitrogen from land running off into the water as we get more and more rains, more rainfall. Again, as a result of climate change. Just as nitrogen fertilizes your lawns and gardens on land, it serves to fertilize the algae in the water. So an excess amount of nitrogen will yield an excess amount of algae. As this algae dies and decomposes, it does two things. First, it takes oxygen out of the water, which is a negative. Most marine critters need that oxygen, as I've mentioned. But it also adds carbon dioxide. So it's a chain of events, it's a long sequence of events, but this increase in precipitation from climate change will lead to more nitrogen runoff, larger blooms, more decomposition, and this addition of carbon dioxide to the water. And the important takeaway here is that anytime you add carbon dioxide to water, the water becomes more acidic. This is what we call coastal acidification. It's near shore, it's local, excess nitrogen leading to coastal acidification. But there's another way we get acidification occurring in our waters. All of the carbon dioxide that gets into our atmosphere, again from the burning of fossil fuels, and that's seen here in the red line. As we increase the amount of carbon dioxide in our atmosphere, about 30% of that gets into our water. That's the blue line. And again, anytime you add carbon dioxide to water, it'll become more acidic, and that's what you're seeing in the green line here. pH is a measure of acidity, and it's a tricky measurement. The lower the pH, the more acidic the system. And small increments in the pH scale are actually large increments in acidity. This is data from the West Coast, from the Pacific, but we're seeing the same drop in pH or increase in acidity right here in Casco Bay. We're back to Friends of Casco Bay data now. This is from Casco Bay showing that over time, we're seeing that same drop in pH or a more acidic bay. So our bay is getting warmer, our bay is getting more acidic. Regardless of how the acidification is occurring, and we see both near shore, our waters are becoming harder to live in. As we add more carbon dioxide to the atmosphere, and as our waters become more acidic, we're also seeing less calcium carbonate. This is data from our continuous monitoring station showing calcium carbonate levels in the water. And again, we only have 2.5 years of data so far. We don't know what things were like 5 years ago or 10 years ago. We will know what they're like 10, 15, 20 years from now. We'll still be out here doing this. But we do know what the current conditions are, and not many people knew this. And I'll explain why calcium carbonate is important in just a second. But it's important to note that we already see levels for the first half of the year below that red line, below that threshold for what is considered healthy for calcium carbonate. The reason I keep saying calcium carbonate, the reason this is important, and again, as we see more carbon dioxide in our waters and in our atmosphere, the waters will become more acidic and we'll see less calcium carbonate. Calcium carbonate is the material that makes up shell. So if you're walking along the beach and you see shells, that's calcium carbonate. So if you're a fan of mussels or clams or oysters like I am, calcium carbonate is important to you. This is a lab experiment done by a scientist right here in Maine at St. Joe's. He took very small clams, like you see here on the left, adding carbon dioxide to the system these clams were living in, so he's making the water more acidic and lowering the amounts of calcium carbonate. After just 1 day the shell has become pitted and dissolving away, losing calcium carbonate back into solution.
That's the same shell?
That's the same shell 1 day later, and this is 3 days later from the first. So it's lab studies and experiment, but a world with less calcium carbonate will be very difficult for shellfish to live in. That's one example of a species impacted, or of shellfish are impacted by a loss of calcium carbonate. Another organism that'll be impacted by acidification are corals. The corals you think of are actually calcium carbonate. It's the skeleton of the actual organism, but I should note that climate change will be very difficult on the corals, not just because of acidification, but again, as we add more carbon dioxide, we're going to see less calcium carbonate. That's going to have an impact on our shellfish, on our corals. And my last example, this critter, this is a sea butterfly, a pteropod. They're very small, they're members of the plankton community, but they're very important. They're a very important part of the food chain. And they have a calcium carbonate shell. So again, we're concerned about the burning of fossil fuels, the increase in carbon dioxide, the decrease in calcium carbonate as our waters become more acidic, and the loss of critters like this. And I'll finish with this slide. Everything in yellow here will be directly impacted in a more acidic environment, a more acidic ocean. I've talked about the shellfish already, the corals, and there's our pteropod, our sea butterfly friend right here in the middle of the plankton community. These are all members toward the bottom of the food chain. And as we do damage to the bottom of the food chain, there will be impacts to everything else. Everything in shadow here, around those things that are impacted directly, will be impacted indirectly. So what we're doing now will have ramifications throughout the food web. That's probably enough bad news. So I will turn things over to Ivy, Baykeeper, who will tell you about what we're doing and how we're addressing some of these issues.